page 310. We looked at one domain. So now let's look at, we did look at actually at adding and subtracting, but we did not look at, yes, please, Victoria. I'm sorry? Yes, yes, I did turn it on. Thank you, thank you. You can ask me anytime, yes. When there is a little pause and I start uploading the first video, so then, please. Let's look at a function composition, for example. Problem 54 on page 310. Let's say we have f of x, which is 5x plus 2, and we have g of x, which is 3x minus 4. When we add, subtract, multiply, and divide functions, they must have a common domain. If they don't have a common domain, there is no point in creating those functions. They don't exist. Here, when we're asked to find the function composition, there is no discussion about common domain. They do not have to have a common domain. So I am not going to request you to learn how to find the domain of a function composition. I think it's a little bit beyond the scope of the course. However, if you find one in my math lab, bring it to class and then we'll look at it, okay? So here's what happens. And I'm not going to ask you this. So in f comma g, this is f of g of x. I did not explain this yet because I looked at Madison and she, okay, good, sorry about that. So function composition. Function composition is the fifth way of creating new functions. It's not addition, it's not multiplication, subtraction, or division. Something totally new. And this is the notation. F comma g, this is one, and this is another, g comma f. Can I create f comma f? Yes, I can continue forever. So f comma g, that's the way we read it. And it's this notation. This is a circle. It does not represent multiplication or any other operation. So by definition, this is f of g of x. And here's how it works. Which of these two functions do you think is the inner function, the function that is applied to x first? G, of course. This is the inner, and this is the outer. So to x, we apply function g to get g of x. And then after we are done and we get a number here, we are applying function f to this number to get f of g of x. And this is function composition f comma g, where g is the inner, f is the outer. So here's a question for you. What does this set represent for g?
Why?
The range, correct? Very good. So this is the range of g. Also, what does this represent, this set, represent for f?
X.
Domain. So this is domain of f. So these functions do not have to have a common domain, but the range of g must work well with the domain of f. So for example, if g has a y value of 5, but f cannot be applied to 5, the chain is broken. So that's a more sophisticated situation than simply finding a common domain. So the range of g and the domain of f have to work well together. I am not going to ask you to find the domain of function composition. I do it with my pre-calculus class, but I don't think it is necessary here. Okay, so we are given two functions, f of x, which is 5x plus 2, and g of x, which is 3x minus 4. And we are asked to find f comma g And then g comp f, what else do they want? And they want to evaluate f comp g at 2 and g comp f at 2. Okay, I have to write a definition, which is f of g of x. I have to replace g of x. You don't have to cross it out like that. I'm just trying to make a point. By 3x minus 4. And now remember how we read functions. What does this function say? This tells me that f of whatever equals 5 times whatever plus 2. So 5 times whatever plus 2. That's my whatever now. So I distribute. I get 15x minus 20 and plus 2, which was minus 18. And this is a function composition. Was determined by the composite, or f comp g, the composite of f and g.
So if f were to have been on the inside, you would plug the number in for the 3x minus 4. Like instead of doing
Yes.
5.
So you want to find f comp g of 2? Is that, Danielle? Is that the?
Because like we plugged in, because the g was on the inside.
Yes,
we put,
g is the inner function.
Yeah,
so that's why
if
that's the first. So I put the inner function inside the outer function. Yes. So now g comp f has the same procedure. Is now g of f of x. So now I have g of 5x plus 2. And this time I have to look at g. And g says to us, g of whatever equals 3 times whatever minus 4. So then this is 3 times whatever minus 4. Whatever being 5x plus 2 at this point. So this is 15x, but plus 6 and minus 4, which is plus 2. So that's how we determine the function composition. Can I have more than 2 functions? Yes. I can have f comp g comp f. I can continue forever. There is no point, though. I mean, there's nothing that I can give you examples on 3 or 4 functions. I can give you examples, but not real-life applications. Now, for example, problem 78 on 311 is h of x equals the square root of 5x squared plus 3. Here, they're asking us to find 2 functions, g as the inner and f as the outer, to decompose h of x in 2 functions. There's more than one correct answer here. I want to decompose them. Okay, so all functions are basically function compositions. Function composition. So how do I decompose this? Here's how I think. If I want to evaluate this for 2, what will I perform first? I will perform 5x squared plus 3. So that must be g of x. When I'm done and I find just one number, let's say 15, what do? What is the outer function going to do? Square root of x, that's it. So then f of x, which is the outer, will be the square root of x. So I decompose the function into 2 functions. I can decompose it in more than 2. And this is not the only answer. So you can find or come up with another answer. So here's 80. Same page. I would like you to decompose this. H of x is the absolute value of 3x minus 4. I would like you to give an inner, and I would like you to give an outer. Inner, outer. As if you are evaluating. Pretty much the same idea. So can anyone give us the inner function here? Perfect example. And once I'm done and I find one number, what function do I apply to this number? Perfect. Excellent. That's it. We decomposed it. I would like to look at a graph and identify or answer few questions from a graph. So let's take a look. So let me just copy the problem first. It's 92 on 311, and it's f comp g of 1. What does this mean? F of g of 1. So first we have to identify and find g of 1. And then whatever that is, I will have to find f of that number, correct? Any questions so far? Okay, so let's do that together. So first we're looking at, I see a graph of the graph of f, which is blue, and the graph of g, which is purple. And I have to find g of 1 first. What do you think is g of 1? Right, g of 1 is -5. But now I have to find f of -5. Yes, f of -5 is 3. Very good. So g of 1 is indeed -5, but this is the number that I have to plug in f. At -5, f is 3. Any questions on this? Is this okay? Yes? Good. So this was -5, and then f of -5 is 3. Any questions here? Any questions? Now, I'm sure you're wondering why function composition. So let's read the problem. Let's say 100 or 102. 102. Okay, so the regular price of a pair of jeans is X dollars. Oops, no one can see anything. Okay. So they say f of x equals x minus 5. That's given to us. And g of x is 0.6x. Describe what functions f and g model in terms of the price of the jeans. So x is X dollars. And what do you think f of x equals x minus 5 represents? A reduction in price of exactly $5. Correct? Okay, let's see what this means. So this is 0.6x. It's a reduction in price by 40%. It's only 60% of x. If I pay x, I pay 100%. But if I pay 0.6 of x, there is a reduction of 0.4, of 40%. Is that clear? Okay, find f comp g and describe what this model represents. Repeat part B for g comp f, and then which composite function models the greater discount of the jeans. So let's copy. We have, that's 102, and the page is 312. So we have f of x, which is x minus, yes, of course, I'm sorry, thank you. Sorry about that. And g of x equals 0.6x. So we know that x minus 5 represents a price reduction of exactly $5. So we take the jeans, we take it to the counter, and they give us a discount of $5. On g of x, however, discount is totally different. Would you like a discount of 40% or a discount of $5? As long as the 40% is bigger, right? So we only pay here 60%. So they want us to determine f comp g and g comp f and decide which one is better for us. So f comp g, by definition, is f of g of x, which is f of 0.6x, which is, and now please dictate. Correct. We replace x. X now is this, 0.6x, and minus 5. Very good. Can anyone explain what this means?
It's a new function.
Correct. But let's see what it means. Yes, so they reduce the price by 40%,
And then take 5 off.
and then on top of that, like they take off $5. Okay, let's see G come back. Are you checking on your ice cream? I didn't hear what he said. Okay, so now G of x minus 5, please dictate. 0.6, but parentheses, x minus 5, which will be 0.6x, but minus 3. So now let's decide which one would we prefer when we buy any item. Would you prefer the 0.6x minus 5, or would you prefer the 0.6x minus 3? Yes. So F comma G is a better deal for us. Questions before we move on to inverse functions? Questions? Inverse functions. When we started functions, we looked at 3 situations. This was one. These are numbers, of course. Here was the next one. Bless you. And this was the last one. And we said something about this one. What did we say?
It is function.
And also one-to-one. Function and one-to-one, because also to each y, it corresponds only one x. To each y corresponds only one x, and to each y corresponds only one x. What did we say about this? Perfect. What did we say about this? Function, but not one-to-one, because this y corresponds to 2 different values of x. So function, not one-to-one. So what we conclude from this is that only, and I'm going to write this note down, only one-to-one functions have inverses that are also functions. This one has an inverse, but it's not a function. So note, only one-to-one functions have inverse functions. Only one-to-one functions have inverse functions. Now let's look at a few graphs. And now you know what they are in your dreams. You don't have to graph them. Four different functions. This one is cubic is this one. Cubic, absolute value, and quadratic. Which one do you think is one-to-one, and which one do you think it's not one-to-one? Remember, now we're not cutting them with vertical lines. We know they're all functions. We know that. We're cutting them with horizontal lines. For each y, only one x. For each y, only one x. For each y, not just one x. For this one, no. For this one. So is the linear function one-to-one? By the horizontal line test. Is the quadratic function one-to-one? Is the x cubed 1 to 1?
Yes.
Yes. Is the absolute value 1 to 1? No. So we use the vertical line test to identify whether it's a function, and we use the horizontal line test to identify whether the function is 1 to 1. So let me refresh your memory on the relationship between the function and its inverse, and also talk about notation. So if this is x and this is f, obviously this is f of x. What would the inverse function do? Will be applied to this and return this. Notation for the inverse function of f. F inverse. It's -1, but it's not 1 over f. So it's f inverse. F inverse. The inverse function of f. So if this is set A and this is set B, can anyone identify the domain of f? A. Can anyone identify the range of f? B. Can anyone identify the domain of f inverse? Of course. And the range of f inverse? They are carved in stone. If the function takes values from A to B, the inverse function has to be defined on B, taking values back to A. Mandatory. Okay, let's see how we determine the inverse function. Can anyone give us a linear function? We said that linear functions are 1 to 1. So give me a linear function and then we'll illustrate how to determine the inverse function for a linear function because it's 1 to 1 and it has an inverse. Any linear function you can think of.
2x minus 7.
Excellent. This is a linear function indeed. So step 1. So find f inverse. Step 1. Replace f inverse by y. Can I do that? I want to replace this notation by y and write y equals 2x minus 7. Will you allow me to do that?
Sure.
Because they are the same. Y and f of x are always the same. Of course I'm allowed to do that. The second step. I am going to swap x and y. And you should say no. So step 2, swap x and y. Here's what I want to write, and you tell me if you allow me. And you should ask why, right? Here's why. We already established that this value is the y value for f. But what does this value represent for f inverse? Exactly. That's the reason why I'm allowed in this situation only, to swap the two. In step number 3, solve for y. Can anyone give us the idea of how we solve this for y?
We get 2y.
We move 7. So x plus 7 equals 2y, or y equals x plus 7 over 2. In the final step, we replace the notation y by f inverse. So f inverse of x equals x plus 7 over 2. And I'm going to say this to you. I have doubts about this. I don't know, well, maybe I made an error. How do I know that this is indeed the inverse function of the original function 2x minus 7.
Granted.
You have a point. We're going to do that in a minute. But before that, let's suppose you have a known amount of money in your pocket. Let's say you have $100. And I give you 3. And 5 minutes later, I come back and say, give it back to me. What is the deal here? Are you richer or poorer? By giving you 3 and taking you back in 3 minutes. Any change? Why? Because addition by 3 and immediate subtraction by 3, no deal. How come? Adding 3 and subtracting 3 are inverse operations. One will cancel the effect of the other. Now, if I give you 3 and I don't ever come back to get it back, it's a different story. But we are talking about 2 operations that are inverses of each other. I give you 3 and I take it back. So if these 2 are inverses of each other, then the function composition in any direction must equal, and must equal what? 1 what? 1 what? You already had your x in your pocket. I gave you 3 and I took it back. What is left? Indeed. This is what we call the property of inverse functions. Only 2 inverse functions will follow this relationship, will comply with this. Only if I give you 3 and I take it back, or I take 3 and then I give it back. These are inverse operations, no deal on x. It's not x squared, it's not x over 2, it's not 3x, plain x. So let's show we have now here 2 functions. We have function f of x that you gave me as 2x minus 7, and we determine f inverse as being x plus 7 over 2, and we're not sure. Or we are simply given 2 functions and we are asked, hey, show that they are inverses of each other. What do I have to determine to show you or convince you that they are inverses of each other? I have to find so let's find f inverse of x, which is f inverse of x, which is f of the inverse is x plus 7 over 2 equals, and now please tell me what is next. Exactly, 2 multiplied by x plus 7 over 2 and minus 7. Of course, we will simplify first. Of course, we have what left? We have x plus 7 minus 7, which indeed is right. So now there is no other way. It must be the inverse function. We would have never gotten plain x if these 2 were not inverses of each other. And of course, f inverse comp f must be x as well. We normally have to show both.
So are we gonna see, like, for like he was saying, if you were gonna graph it,
Yes.
what would you want? If you're looking at it,
Let's graph them.
See?
That's our next step. It's awesome suggestion. So we have these 2 functions, and we want to graph them on the same coordinate system. So that's our next step. Graph f and f inverse on the same coordinate system. We call it Cartesian system, coordinate system, you know what I mean. Okay, so for f of x equals 2x minus 7, we want to find the x-intercept, and we want to find the y-intercept. When x is 0, what do we get? And when y is 0, what do we get?
X is 0, y is -7.
Of course. So 0, comma, -7. And when y is 0, we have to move 7. So we have 7 equals 2x, or x equals 7 halves, or 7 halves, comma 0. Is this okay so far? These are the x and y intercepts. Okay, very good. So let's plot those. And you see what? Something very interesting will happen. Sorry, my lines are not very straight. Okay, so I'm going to plot 0, negative 7, 1, 2, 3, 4, 5, 6, 7. And I'm going to plot 7 halves, 0, 1, 2, 3, 4, 3 and a half. I'm going to connect and extend the line. I'm going to write, like always, y equals 2x minus 7. And now I refuse to find other points. From what we have, I would like you to determine or give me 2 ordered pairs that will help us graph the inverse function. What do you think? Okay, here's my hint. Say it again.
So you do 72 on the y.
Of course. Because if I have 0 going to 7 halves, I'll have to have 7 halves going back to 0. That's why I was giving you the hint. I don't need to create other points. This point was at 0, negative 7. You will go where?
Negative 7, 0.
Exactly. 1, 2, 3, 4, 5, 6, 7. And this point was at 3.5, comma 0. It will go at, so 1, 2, 3, good. So this is F inverse, which is x plus 7 over 2, guaranteed. So something extremely important happens. As you see, these are reversed. And you will tell me what happens here. Of course, my graph is not perfect. But what happens is they will be symmetric with respect to the line, and we know which line this is. What line is this? We grafted the first in transformations. Very first function. What is it? The linear. Y equals? Indeed. This will always be the case. The graphs, and we're going to write this in a minute, the graphs of the function and its inverse forever will be symmetric with respect to the line y equals x. That's exactly what we did. These two are equidistant from this line. These two, equidistant means equal distance, equidistant from this line. So note, the graphs of f and f inverse are always, we're not talking about odd or even functions. I'm only saying that the graphs are always symmetric with respect to the line y equals x. For any function and its inverse, they will be symmetric with respect to y equals x. Very good point. I was going to show this anyway. So for example, in this graph, let's choose one that is 1-to-1, and I'm going to grab my pencil. If I have one, yes, I do. It's right here. Okay, so please choose a graph, any. Which one? 38. Is this 1-to-1? You picked a wonderful function. It's going to come up in chapter 4. Is this function 1-to-1?
Yes.
Good. So we're asked to graph its inverse. Please give me some points so I can graph the inverse. You said 1, 0. Awesome. So -1, yes. 2, -1. Very good. Where the function crosses y equals x, the inverse must cross, because this is point like 1, 1. Reverse 1, 1. It's still 1, 1. So here it is. Here's the graph. This is the graph of f, and this is the graph of f inverse. If this point one more time crosses the y equals x, it means that the y and the x are identical, and when you reverse the point, you'll still get the same point. Very good. So now I would like to look at this table. I don't know, will you choose whatever you want from there? We're asked to, f and g are defined by the following tables. Use the answer. So please choose whatever problem you want, and let's work on it. I'd like to look at 58. So we're asked to find f inverse of g of 1. So look at the tables and determine g of 1 first, of course. G of 1 is? Perfect. G of 1 is 1. But now we want to find f, I'm going to erase all this, f inverse of 1. I go to f. So f inverse of 1 means I'm applying the inverse function to the y value. So I go and I see 1. Okay, what will be the answer? -1. Let's also do g comp f of -1. What do I have to find first? F of -1. Okay, f of -1 is 0. But now I have to find g of 0. Oh, I'm sorry. That's f of -1. My apologies. So it's 1. And then I need to find g of 1. So g of 1 is 1. Perfect. I would like us to determine one more inverse function. Oh, yeah. Yeah, I want to look at this. Okay, so let's read the question. The graph represents the probability of two people in the room. This is a famous probability question. The graph represents the probability of two people in the same room sharing a birthday as a function of the number of people in the room. So we are, let's say, 15 or 20 people in this room. What is the probability? So 20 people. What is the probability that two of us have the same, shared the same birth, not year, but just the same May the 5th? So that's even better. So so this is 45%. So if there are 20 people in the room, the probability that two of us share the same birthday is about 45%. Look what happens if we have 60 people in the room. What is the probability if we have 60 people in the room that two of those have share the same birthday? But now the question is different. So by the way, is this a one-to-one function? Does it have an inverse? But what they're asking us is this. So let's find f inverse of 0.7. How do I do that? F inverse of 0.7. I am given the y value, and I'm asked to determine the starting point, right? So what will be f inverse of 0.7? Right, which means if I want to ensure, according to the model, if I want to ensure 70% chances that two people in the room have or share the same birthday, I should have 30 people in the room. Let's do one more, either 0.25, f inverse of 0.25, or f inverse of 0.5. So which one? 0.25. So the probability of 0.25 is somewhere here. And I read the number of people in the room that should be present to ensure it's a low probability. 25% is low, but that's what I want. 25% chances that 2 of us share the same birthday, we should have roughly about 15 people in the room. So that's based on all inverse functions. Questions? Questions? Okay, I'd like us to look at one more example of finding the inverse function, and it's domain and range. So can anyone give us a radical function, square root? Oh, thank you. Can anyone give us a square root function? What is it? X minus 16. Excellent. So this is indeed a square root function, and we're asked to find the inverse function. That's our question here. Since we learned transformations, we know what we have a picture already. So we know the square root is this. Where do I shift this graph? To the left or to the right? To the right 16. So I know the domain, right? So I have to write that x minus 16 is greater or equal to 0, or this will be the domain of f. 16 to infinity. Do you all agree? Picture the graph and please give me the range of this function. We already pictured the graph, and the range would be? The range will be? The range will be? Just remember the graph. The square root of x shifted to your right 16. What about the range? Of course, it's a square root function. No questions there. Now I would like you to give me the domain of f inverse, and you can say you haven't even found it. I don't even want to before I find the domain and range, because it's the domain and range are carved in stone for good. What will be the domain of the function that we will determine as the inverse function? Of course, there is no discussion there. And the range of f inverse, it's carved in stone. I can do anything. Absolutely. They go together. Otherwise, they will not be inverses of each other. Great job. Now I'm ready to find the inverse. So please find the inverse. Tell me the first step. Step number 1. Correct. So I have now y equals the square root of x minus 16. Excellent. Number 2. Then x is now the square root of y minus 16. In step number 3, you will identify the type of equation and you will say, I know you have to do blah, blah.
Yeah, where our square looks at.
Excellent. So x squared equals y minus 16. And I need to solve for y, and I get x squared plus 16. And then you will say f inverse equals x squared plus 16. And I'll say problem. No, we can't simplify. But why am I saying a problem here? So here's x squared. Where does this go? Up 16. But is this a one-to-one function? No. However, it comes with this domain. So it's only this piece. And now it is one-to-one. It's only from zero. Exactly. This function is not one-to-one. So when you graph it, you have to be very careful. Let's graph both on the same coordinate system. So you already told me how to graph. So let's say 4, 4, 4, 4. This is 16. So this is the square root of x minus 16. You don't need to tell me anything about the other function. 4, 4, 4, 4. I know how to graph it. And of course, y equals x is in the middle. If I make the error to continue this on this side, obviously there are not 1-to-1. This was not going to be 1-to-1. And the inverse of this graph cannot be this. So careful. We can, the story here is that obviously even a quadratic function can be turned into 1-to-1 as long as we say we truncate the domain. We chopped it off. This part is gone. And now these two are symmetric with respect to y equals x, and they are for sure inverses of each other. So that's why I determined the domain first, to see what's happening here. Any questions? Any questions? Any questions? Okay, the last section of this chapter deals with three things.